Hello guys! Hello everybody! This is again another singer to the voice. Welcome to my part 2 of scaffolding and working at high safety. So we need to have part 1. It's more on the basic foundation, the theoretical aspects. It's more on the overview. But here in the part 2, I will be able to discuss some important technical specifications and requirements, what to be considered before scaffolding erection, dismantling, modification, and alteration, and of course, in working at height above 1.2 meters from the ground. Okay, you know already what are those safety requirements prior to work at height. Okay, so working at height is more on a general point of view. So there are a lot of type of work. So usually the work can be done through a higher elevations. Actually, it depends on the height of your reference point actually, because there are also working at height that the vertical distance are not very high. Let's say, for example, below 1.2 meters, which is the standard of general industry and OSHA standard, but it is critical job, even though the vertical distance and the vertical height is not very high. So in that manner also, we are not very bookish, okay? That we always refer to the book in that situation. We need also to adopt a practical approach in safety because it doesn't discuss there that if it is less than 1.2 meters, okay, you have to do the safety requirements at all. But if you are an occupational safety and health professional, you will be able to analyze and evaluate that this is also very necessary, even though it is not outlined in the OSHA standard that you have to have this implementation of working at height safety requirements to be followed or implemented, even though that is not above 1.2 meters high. Okay, we will use our critical thinking in that aspect and in that manner, right? Because there are also activities or working at height that is below 1.2 meters in vertical height or vertical distance that are very critical in operations. Okay, it depends on the scope of works to be done. Okay, that is very clear. Any questions so far regarding that one? You can object me if you wanted to also. You can share your information to me also. Let's have brainstorming here, the sharing of ideas, because more heads is better than one. Okay, there are things that I never knew yet. Okay, but you know already. Okay, but there are also things that I know already, I knew already, but you also don't know. So we need to share ideas and information. That is what we call as brainstorming. Initial technique to come up a very reliable and effective documentation, whether it is a procedure or it is a policy statement or it is a program, whatever programs you have in your company. So we need to start in a brainstorming, meaning we need to share ideas already. Okay, but specifically, this is working at high. The topic is very specific. Okay, now going to scaffolding, erection, modification, alteration, and dismantling, we have certain criteria to follow, especially the technical specification. So by the way, I'm using only the specification sorry, for Saudi Aramco because I've been working also in Saudi Aramco as a safety compliance field coordinator. Okay, something like that. That was in 2014 as far as I could remember. Okay, something we need to insert that here, okay, in combination to some standards also in OSHA standards, particularly the OSHA standard general industry or the OSHA standard construction industry, because not many know that there are separate industry standard. And sometimes, though all not knowing this, some knowing this already, you will not mix up these two standards because the specific standard of general industry will not be applied also sometimes in construction industry unless that is a general and generic safety standards that could apply both. Okay, but there is a specific criteria. For example, I misstated this directly. Okay, in OSHA standard for scaffolding for general industry, the main requirement for general industry that all scaffolds can be erected with a competent personnel and experienced personnel. Okay, take note. It doesn't specify there that it should be supervised by a supervisor or engineer that are trained and having adequate knowledge of scaffolding safety training or whatever, chuba chuchu. Okay, now in construction industry is different. Before you be able to erect, dismantle, alter, and modify a scaffolding structures, it should be completely supervised and monitored by a competent scaffolding supervisor, scaffolding inspector, and scaffolding engineer. So there's a difference, right? It's very clear the difference because in the general industry, as long as they are competent to erect, dismantle, and modify, so it would be okay, even though there are no supervision of those highly qualified immediate superiors. But in construction industry, okay, there must be a close monitoring and supervision for those scaffolding inspectors, supervisors, engineers that are highly trained to supervise the erection. But it is common to both the general and construction industry that they are, or the scaffolders are trained both on how to erect the scaffold, how to modify, how to dismantle, and how to alter the scaffold structure. Okay, now in the part one of scaffolding and working at height training, I've discussed the definition or definition of, you remember what the definition of scaffolding? So, okay, let's go back to the basic definition. Oh, sorry, my friend. Oh, my connection is unstable. Oh my gosh, I'm coming back. Okay, sorry, do I speak too fast in this part two of scaffolding and working at height, sharing information to you guys? I think so. I'm very fast talking, right? Okay, forgive me because if I will never speak that much in a fast mode, I'll be able to, forget the substantial or important information that as far as I could have to do right now, I will be able to do this verbatimly, spontaneous. Okay, and or shall I let you do this fluently? Fluent in English. Okay, something like that. Okay. So before we go further to the working attendant, let's touch first the scaffolding safety requirements. Okay, scaffolding. Okay, scaffolding is any temporary elevated structure that is designed to support personnel, tools, and equipment. What do we mean by a temporary? Meaning to say that is not permanent. Okay, that it will be dismantled after the scaffolding structure has no use at all. So it's very clear there. Okay, you have to dismantle after its designated purpose. Okay, so because the word of temporary elevated structure, okay, meaning that is not permanent. So it is really a requirement after the erection. Okay, then afterwards, after the work of scope to be finished in using the scaffold structure, then you have to dismantle. Now we will still also review the main hazards of scaffolding. Again, the instruction flashed in front of me. Your connection, oh my God, and come back already. Sorry for the weak connection, really. Okay, sometimes there's a weak connection, and sometimes, and after this, live streaming during the uploaded video processing, then that my voice will be stopped for a while, and there will be a like of stoppage. Sorry for the quality sometimes, because sometimes we have very weak connection for the network provider here. But if you just listen very well, because I've spoken to you or speak very, very clear, right? My English is very clear. You can understand. I think so. As much as I could, I will be able to avoid higher or deeper technical terms or terminology. Okay, I will just use simple terms that are easy to understand or common terms that are easy to understand so that I can clearly convey the proper message to everybody so that you can also clearly understand very easy. very easily, sorry. Okay, I forgot to use the correct, pronoun for statement. Never mind the grammar. Sometimes I exchange the adverb, the adjective sometimes. Okay, like for example, more easily, easy. There's a difference between a pronoun and an adjective, right? So an adjective, you have to describe a certain thing, right? But the pronoun is more on a different thing. Okay, so forgive me. In a way, we are not here to live stream regarding English grammar. We are here to on technical information about scaffolding. Okay. Now, before going further, did somebody hear my or attended my part A or part one scaffolding and working at height, sharing of information to everybody, guys? Okay. Did I mention the type of scaffolding? I think so. I mentioned, right? But let's review also. Okay, we have a lot of types of scaffolding. The basic one is the bamboo scaffold, timber scaffold, sorry, and the wood scaffold. This is mainly used in our house. Okay, because in our house construction, there will be no safety officers there to check regularly if the workers are working properly, if the carpenters are working properly, something like that. We are just monitoring them by our own safety of our workers because we pay money to them, okay, in order to build our house, something like that. Okay, so if we do the work at height, for example, the rooftop works like rooftop, okay, in creating, installing of the roofs, the galvanized iron sheet roofs, and then they will be able to provide also in some or most cases, right, a bamboo scaffold, okay, that is common in most provinces, and timber scaffold, or it could be a wood scaffold. Because if you try to use really scaffold grade plantings that are expensive, okay, normally we don't do that, okay, because that is not a company purpose type of job, only our home. So that is the first type, the bamboo scaffold, the timber scaffold, and the wood scaffold. Okay. The second type, we have the Trestle scaffold. Oh, Sir June, first unfamiliar word for me. Yes, even me, that's unfamiliar word for me also. Trestle. Okay, I'll show you the schematic diagram or a drawing of a trestle scaffolding, something like that. With while. So I have a time limit for this live stream because I have also another appointment. I'll be able to do my regular workout every Saturday, right? As far as I could remember, as far as you could remember also, because I'm very, very vocal and straightforward to share to you guys my appointments every day offs of mine, like that I'm sharing to you, right? Okay, my appointments during day off, something like that. Okay, I'm doing my regular workout to the gym, something like after this live streaming. Okay, so it looks like this live would be limited. Something. Okay, but don't you worry. As much as I could, I'll be able to go directly to the topics. I'll never insert another topics to connect with. Okay, that's it. Okay, where's my pencil pen? Oh my gosh. Press two, no? This is scaffold work alright. Okay, something like that. Oh, I have a red pencil pen. Red. Okay. I love red. So, red stands for bravery. Okay. So, okay. Trestle scaffold. Pasensya na if you are not really interested to this live streaming because most of the audience or audiences available for this type of live stream are those working in the construction industries. Okay, or in general industries also. What we mean by general industries are 24 hours in producing various kinds of products. It could be solid, liquid, or gas products released in the market, whether it is locally or internationally. The construction is still not yet finished. They're erecting some foundations like that, and there's no operation yet. And it is not clearly a running plant yet. So that's the difference. And also OSHA standards have a clear distinction or difference when to apply those standards could it be in general industry and in the construction industry? Because some other also professionals, occupational safety and health professionals, they will apply to general industry. They don't know that it will never be applied anymore in general industry. So take note for that. Be smart enough also, okay? So do not always insert the standards you know already in your brain, okay? Study well, evaluate well. What is the difference and the applicability for that standard that is designed for technically? Okay, something like that. Be smart enough to review before throwing various safety instructions in your company or safety procedures or policies or whatever programs in your companies that you are in now. Okay. Going back to the example, which is the digital scaffolding. Okay. Like this. Okay. Oh my gosh. This is only side view, okay? I cannot draw the top view. Remember in engineering drawing, right? If you're an engineering student, okay, like that, you have an engineering drawing subject in your, in your college list, right? There are top view, front view, side view. I'll be showing to you already just the side view, okay? Or we have the aerial view, okay? So aerial view, basically the top view, right? Okay. I will show you the basic on here because it's a general, could be applicable to anybody, something like that. Okay. Okay, class. Ciao. Okay. Anyway, this is very far from my profession being a chemical engineer because this is an occupational safety and health based on general industry and also there's no chemicals involved here. Okay, I cannot input the chemical reactions here. Okay, but due to my experience in OSH, I could also say that I could share adequately some of the not all, some of the information regarding OSH. Okay. Okay, like this. Okay, this is a crystal scaffold. Take note. We have the top rail at the top. We have the middle at the center, of course. We have the footings. Okay, the foundation or the footing are just the same to add support for the stability of your scaffold structure in order it will not be collapsed easily. Something like that. Okay. Okay, so now directly I will tell you the technical specification or standards on the top rail. Actually, the general and construction industry have common standard for the top rail. It should be 0.38 meter, something like that. Okay, I'll show you. Okay, sorry, let's just do this by inches. Okay. Because I really most convenient in inches. Actually, you can convert that using the conversion factor. It shows the same results. Okay, like that. Right in your algebra, you can convert later if you want to convert it in millimeters, in meters, or whatever you want to do. Okay, this is top rail. Okay. So this is, shall I say, 38 inches to 45 inches. Okay. The vertical height of a top rail is 38 inches to 45 inches. Okay. So if I will convert this in meters, it runs to about something 0.9 meter to 1.15 meter. Like that. Okay. So in construction industries, most of the times it reaches to 42 inches. It's our standard height or vertical distance of our top rail from the platform plank. Okay, this one. Okay, not the two-board, because the two-board top, that is not the measurement. It is on the working platform. Okay, here. Okay. So this is the paper. I cannot show you the actual platform. Okay, just analyze also what I am discussing. Okay, and now our mid-rail. Okay, our mid-rail will be charlottes. The half of this value, okay, by theoretical aspects, the half of this value. For example, if we have 38 to 45, we just divided by 2, and that would be our basis. Okay, 38 divided by 2, so that will be the minimum. And then 45 divided by 2, that is our maximum, as simple as that. Then if you try to convert that mid-rail vertical height into meters, as far as I could remember without any computation, okay, it runs to about 45 meter, for example, on the, okay, do not be what do you call this one, bookish, just convert that later if you want to, okay, 0.45, okay, like this, meter to 45 divided to something 0.9, something like that, okay, okay. Okay. Sorry. 0.45 to 0.65. Something like that meter. Sorry, very dirty, right? 0.45 meter to 0.65 meter will be our mid-rail equivalent to divided by this by 2. Okay. This is a threshold. Anyhow, our standards for top rail and mid-rail vertical height and distance will just be the same to the other types of the scaffold. I'm just showing you early the technical specification of vertical height of the top rail and the mid-rail. Okay, number 3 type, we have the bracket scaffold. The bracket scaffold applicability, or it is designed to be attached directly to the wall, inside and outside the vessel, or it could be a tank, it could be a very large process vessel, or let us say, yes, a tank, or any pipeline, okay, large diameter pipeline, okay, so outer and inner. So I'll show you a drawing also. But in this situation, some parts of the scaffold will be avoided because it's only being attached and there's no ground, of course, by common sense. Okay, sometimes, actually sometimes I think so because I'm not a certified scaffolders. I'm not really not having that, rigid and solid technicalities regarding scaffolding. But this is only an information. But I think there's no sole board and base plate for that because there's no ground by common sense. That is the soil. Okay, so what you will able to do is like this. Just to understand that the inside wall of a vessel. For example, this is a tank, a process tank, something like that, okay? This is gonna be like this. This is a process tank. Oh my gosh, it looks like my live stream is very detailed. How can I finish this early? Oh my gosh. So process tank. Oh my gosh. And the bracket scaffold also could be applied if that is not really logical and practicable to put in the ground. Like this, okay? You don't have to put that in the ground because your job is somewhere in the walling, like that, or near to the wall, or something like that. So why you should put your scaffold structure on the ground? Common sense also, okay? Like that. So this is the wall, okay? The outside wall and the inside wall. Sometimes the scope of works are in the outside portion, and sometimes the scope of works are in the inside portion. For example, during maintenance activities, shutdown activities, or any breakdown-related activities from a running plant, okay, or any emergency situation that we have to erect a bracket scaffold that is necessary to complete the task safely and effectively, then they have to do that. For example, this one, okay, it's attached to the wall, okay. But again, going back, the competent personnel and experienced personnel will erect the scaffold, Okay, that means they are certified scaffolders or erectors. Period. No more debate. Okay, something like that. So this is gonna be like this. A side view again. Oh my gosh. This time I'll be able to put one person as an example. Okay, like this. Oh my gosh. It's just like this, the scaffold, no, the bracket scaffold. Can you see? Bracket scaffold. So there are parts of the scaffolding structure that will be eliminated. The base plate, the sole board. I think they will never put that. If correct me if I'm wrong, huh? Okay. So they will only build up or develop more cross braces or diagonal braces as our foundation support to your work platform or the boarded blocks, something like that. Again, for the bracket scaffold, the standards height or vertical distance of the top rail from the scaffold block platform is just the same. It will never change, okay? Mid rail like this, but the foundation is not the same with a trestle scaffold. It's gonna be like this, okay? Very clear. This is a bracket scaffold. Okay, number 4, we have the most common one. We have the tube and coupler scaffold. Okay, it could be a tower, mobile scaffold, or it could be a tower fixed scaffold. Fixed meaning it will never be moving. It will never move. Okay, and there's no wheel and lock in the bottom foundation. Okay, something like that. Because there are two types, right? The scaffold rolling mobile scaffold and the fixed tower scaffold. Okay, that's usually very high. Okay, like that. First section, second section, third section, fourth section, blah blah blah, so on. So, okay, that is tube and coupler scaffold. That is tubing based on scaffold tubing. Okay, like as a pipe. Hot dip galvanized pipe. It should not be painted, huh? It will be only painted a little bit as a sign, an indicator who are manufacturing that scaffold tube. Okay, so that they can easily trace that tube is coming from their company. Or an internal indicator, identifier that this scaffold tube belongs to them. It will be yellow, but only small paint or marking. It's not total. You'll never see a scaffold that are colorful. Okay, no, there's no yellow, orange, pink, because it's not allowed in OSHA standard to have a painted scaffold tube and coupler scaffolding structure. Okay, it's always the color of that scaffold tubing pipe fabrication specifications when applied, something like that. Okay, for example, I will draw this a pipe. Okay, this is a pipe, right? Oh my gosh. I'll just put that here because to save and to conserve energy resources, I have to use scratch papers back to back before throwing in the trash can. Okay, like this. So this is like this. Okay, this is scaffold tubing. Oh my gosh. So like this. In our algebra, if you are an engineering student also, okay, or if you are an engineer right now watching to me, if you agree me, or of course you have to agree sometimes, okay, like that. So this is our pipe, okay, hot dip galvanized pipe that is, meeting the standard of ASTM A3120, equivalent to European standard, sorry, EN 10,240, or the quality coating B.1. That is a specific standard. Okay, so you have to memorize that technically also, especially if you have to erect a very safe and standard world-class scaffold structure. Again, this is basic by Saudi Aramco standard, and Saudi Aramco standard also are very basic in UK standards. and a little bit of United States of America OSHA standards. Okay, they compiled that in one book or manual in their scaffolding topics. Okay, something like that in their procedure, blah blah blah. So this is what we call as scaffold tube. So this is scaffold tube specification. This is the scaffold tube specification. Will be pasted again. So if you try to jot down, so just jot down there, ESTM, okay, like that, 1, 2, 3. It's very easy, right? 1, 2, 3, okay? And then European Standard, EN, or European Standard Committee. EN, capital E, capital N, okay, 10,240, something like that. Quality coding, B.1. Capital B, not small letter B, something like that. Okay, so the nominal outside diameter for this, you should memorize this one because some interview also have this kind of interview, especially if you are an OSH officer or inspector. There are also a lot of interviewers, especially me before. They interviewed me, but I did not answer perfectly. I'll tell you honestly, okay? Then, oh my gosh, that would be a lesson for me. That we have also to study technical specifications because I focus more on the basic foundation. As an OSH, I focus more on the basic foundation safety knowledge. For example, I learned to know the basic definition, the theoretical aspects, like the types, the kinds, okay, the applications, the major hazards like this, the risks involved, but I'll never go to the technical specification out of that. But there are a lot of companies that will ask you for that technical specification, especially if you are applying for scaffolding inspector, okay, safety inspector, or you are an HSE engineer, especially if you are accepted to become an HSE engineer that is specifically assigned only to inspect one particular area relating to scaffolding, erection, modification, alteration, and verification. Meaning to say, you are only assigned in a specialized category on the scaffolding issues, something like that. You have to know that technical specification because there are also sometimes that you hire a safety officer for this, you're a safety officer for this, you are a safety officer for maintenance activities only, you are safety officers for the electrical department only, you are safety officers for the scaffolding department only, and you are a safety officer for the overall department as a one safety general function, a general minister or running plan. So you should be taking care, read your qualifications and requirements before applying to those interviews. And that's my fault also because I did not scrutinize the complete credentials and qualifications. It's being mentioned there that it should be assigned in the scaffolding activities related tasks. The safety engineer, that will be hard. I forgot that also. Of course, we'll ask for technical specification. Okay, like that. But in those times, though I memorized a little bit, but not all. But what coming up in the interviews are the deep one. Deep meaning it's more a kind of difficult specification I cannot answer. Okay. And through that, I think there are 2 questions. And I did not choose it as a safety engineer there. That's in quiet, okay? Quiet, Quwait, okay? Before here. I was accepted because I did not answer perfectly those technical specifications, okay? And he asked me a lot about Aramco, blah, 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 so and so, okay? The 2 questions are being answered, okay? Outside diameter, that's what we call a nominal outside diameter here. Okay. See? My gosh, what time already? Oh my gosh! Time consume talaga siya. Okay. So, this is the outside nominal diameter and the inside diameter. Okay. So, I think this diameter issue will be applicable in thermal insulation. Right? You have to take the inside diameter and the outside diameter for thermal conduction or thermal conductivity during insulation. Okay, activity also. It's also part in the construction activities. There's an insulation type of work. Okay, we need to have that inside diameter, outside diameter. But this 48.3 millimeter, 48.3 millimeter or 1.9 inches. 48.3 millimeter or this 1.9 inches is the outside diameter thickness. Okay, meaning thickness, thickness. Okay, so outside, not the inside. Okay, something like that. So this is the standard. If the interviewer will ask you, by the way, what is the standard nominal outside diameter of a scaffold tubing in erecting a scaffold tube and coupler scaffold structure? And the answer will be this. Okay, 48.3 millimeter or 1.9 inches. If you answer a little bit closer, of course, it is self-explanatory that the interviewer will accept your answer because it's very closer to the standard. Because sometimes 2 inches will be considered also. And that's very rare with 1.9, right? It's closer. But the problem is if you will just try to predict and very far from the standard, and it's a very minus to the interviewer. That's wrong. Okay, like that. And then there's the scaffold tubing specification. This is based on, okay, ESTM. You remember one of my vloggings, I defined what is the meaning of acronym ESTM. This is, okay, capital A, 1, 2, 3, and European Standard EN 10,240. Quality coating. Okay, meron talagang quality. Okay, coating B.1. Okay, something like this. Okay, memorize this. Okay. Who knows? You will be assigned as a OSH officer or engineer, and you will be guiding those scaffold erectors or scaffolding team. Like that, then you can guide them. It's gonna be the technical specification, something like that. Okay, like that. Okay, now that is for the tube and coupler scaffold. Okay, and now, okay, we will just try to examine first. If we're going to the other types of scaffold, there's a lot. But before that, okay, so before purchasing the scaffold tubing or scaffold tube materials, I'm really referring to the tube only. I'm not really talking yet to the couplers, to the base plates, to the sleeve couplers, right angle couplers, the spike or the joint pin or the connectors or whatever, tube. I'm still explaining to you the scaffold tubing. Okay, the scaffold tubing. Okay, the scaffold tubing criteria. What do you mean by criteria? Or the parameters to discover before buying. Okay, we need to check the physical properties of the scaffold tube. Okay, we need to know the tensile strength. That is mathematics or in strength of materials in in engineering, right? If you have a civil engineering graduate, so this is their expertise, strength of materials and engineering mechanics. So since we are all in engineering courses and we study all the strength of materials and engineering mechanics. So it's under the subject of strength of materials that we'll be able to study further regarding to tensile strength. So before purchasing the scaffold tubing, we need to know the tensile strength. Okay, number 2 criteria, we have the actual yield. Oh my gosh. Okay, the actual yield or the yield stress. And then number 3, the percent elongation of that scaffold tube, that it will pass to the certain specifications of, again, another number, ESTM-A, capital A, 370, or European Standard EN 10,200-1. Oh my gosh, Sir Sotero, there's also a criteria. Yes, because the money is coming from the company. And they will never give you a value without, a great purpose for that. But it should be worth it. Worth it. If you buy that one, it is understood to be durable, long-lasting, efficient, safe, quality, efficient, okay, durable, that it will endure for a long period of time for constant using. Something like that. Those are the four criteria to be considered by the company before purchasing any materials or tools, something like that, in a certain organization or a certain power plant, whatever. Okay, something like that. So, memorize this also. Okay. I think this is the job of the purchaser, but it's very important also for the procurement department, by the way. Okay, because they have one department, right? The procurement department. And there is a purchasing officer there, something like that. And you need to have the specifications, okay, before doing the quotation. Okay, something like that, to buy those scaffold tubing materials that will be used permanently in your organization or in your plant or in your company. Okay, the scaffold tubing specifications are this. Okay, number one, it meets ESTM. Okay, capital A 370 EN 10,201. Okay, class, we don't have an examination for this, okay, but just try to remember a little bit. Though we cannot memorize everything, and we also cannot memorize everything because I'm very old. Not very old, I'm getting older now, and then my memory retention is not very quick and fast as compared to my younger days also. Okay, really. Okay, this one. ESTM, American Society for Testing Materials. So this will be very important standard for engineers, particularly mechanical engineers. They're usually using this standard, ESTM. Okay, American, okay, Society for Testing Materials, ESTM. Okay, capital A 370, EN is European Standards, acronym ODI. Okay, 10,200-1. Okay, this is for the technical specifications for the scaffold tubing. Okay, scaffold tubing before you buy it in the market, so that you can erect the tube and copper type of scaffold structure. Okay, something like that. And you need to have the steel tubing specifications that it meets the hot dip galvanized requirement. Okay, not painted. This painted scaffold tubing is not allowed really. Okay, sure, 100%. Okay, something like that. Okay, so we need to determine the criteria. Okay, the percent elongation, the actual yield or the yield stress, and the tensile strength. Okay, of the scaffold tubing, something like that. And that is for the tube and copper scaffold. And to go directly with other type of scaffolds, we mentioned already that trestle scaffold, the bamboo and scaffold, the tube and copper scaffold. We have also the bracket scaffold, we discussed it already, and we have also the overhang and suspended scaffold. Okay, we have that also. A rolling and mobile scaffold, a tower and mobile scaffold, something like that. And we have also the kind of scaffold that erected under the bridge. Okay, what's it called? Gondola. I think gondola is more on like a suspended scaffold. I think so. I'm not really sure because I'm not really a scaffolding engineer. Okay, but based on what I've learned, but correct me if I'm wrong, there's a gondola scaffolding structure also. And we have also system scaffold, section 1, section 2, section 3, 4. It applies to tower scaffold. Okay, like that. And we have also system fabricated tubular frame scaffold. Fabricated frame by frames. Okay, and we have also welded tubular frame scaffold, but by means of a welding operation. Okay, they fabricated. But the system tubular frame scaffold we buy directly from the market without any welding to be done. But this welded tubular frame scaffold, they just buy the materials and then they fabricate through welding. That's why it's called welded tubular frame scaffold. Okay, something like, did I miss some types of scaffolds? I have only 8 scaffolds mentioned. I think there's a lot, right? Okay, but I cannot uh, remember on the spot also. I mentioned only 9 or 8, something like that. Okay, so that is the standards, blah, 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 so and so. Okay, gosh. And now we go to the parts. What time already? 3:19 in the afternoon. Go to the powder dollars come up. 96.3. Traveling around. Okay, now we go to the different parts of a scaffolding. Okay, now I think there are 13 parts of the scaffolding, but some books are really separating the top rail and middle from other parts. But I'll just have to include this top rail and middle door on the parts. Okay, just like that. Okay. Okay, parts of a scaffold. Okay. Guardrail system. Charot. Guys, just memorize that. If you're really an OSH, just memorize, because we cannot prove something for this, because this is not a mathematical formula, and this is not a scientific law or a scientific formula or equations that we need to derive before getting the exact formula. If we forgot the correct and exact formula, okay? There's no formula here, so automatic we need to memorize, okay? Why guardrail system are being there? So can we prove? No, we cannot prove that one. As long as we know the guardrail system is a requirement in doing a scaffold. So you need to memorize the types of scaffold structure. Okay, we cannot prove something here. We cannot do the trial and error method here, or a series of experimentation to prove our scientific research in science. We are not like that here in the scaffolding safety information. Okay. Our system comparison. Oh my gosh. So top rail, mid rail. Okay. Other textbooks and other scaffolding reference manual, okay, they don't include the two board in the guardrail system. And other textbooks also regarding scaffolding, they also separate the two board, but they put the false upright meaning the punchon, as a part of a guardrail system. Okay, but me, subjective again, my own technical, not really technical, subjective, by my own opinion and knowledge, I need to put the two board. I will discuss why. Okay, 1.3 is the two board. Oh, if you try to restrict also, we should put also the punchon and the false upright. But me, I will never just include the punchon or false upright. 10. Okay. Okay. This is our test scaffold, right? I drew already. Okay, I iterated a while ago. This is our two board. Okay, our two board thickness, okay, is meeting 25 millimeter or 1 inch. Okay, two board thickness. Okay, technical specification of a two board thickness. Okay, 25 millimeter are simply equivalent to 1 inch. It's not lesser. Okay, it should be a little bit higher, but this is a standard, and you have to follow, right? But there's a slight tolerance or allowance, but it should not be very big also, because this is a standard thickness. But it should not be lesser, because the more it is being thick, the more it is safe, of course. The more it is thick, the more it can sustain for the stability of your guardrail system compared to its thickness, common sense, right? So that's why it should not be less than 25 millimeter or 1 inch thickness of a two board. Okay, but it is better higher than that. But by standard, it should meet this requirement, technical specification of 25 millimeter or 1 inch. This is our two board here. Okay, don't you worry, because the parts of the scaffolding will just be general, similar to other types of scaffold. Okay, there's other types of scaffolds that will be tried to be eliminated, especially the bracket, right? But not all the time. Okay, most of them have the complete parts also. Okay. This is our two board. Okay, like this. Okay. Okay. So this part, oh my gosh, what's happening? Oh. Sorry, guys. Okay. This top rail, top rail, mid rail, two board. This is composed as a guardrail system. Okay. The guardrail system is composed of top rail, middle, and two board, but some reference scaffolding materials, manual reference materials did not include two board. They changed it with false upright and puncheon. Never mind, as long as we know the parts, right? Okay, that would be okay, like that. The guardrail system, okay, the guardrail system can support a minimum weight of 300 kilograms and 900 pounds. This guardrail system. Okay, that is for the minimum. Meaning to say, for the low duty applicability only, because you have also the low duty scaffold, the medium duty scaffold, the heavy duty scaffold, right? It depends on the situation. What type of scaffold structures you'll be able to erect based on the actual conditions on the specific location where you're going to erect the scaffold structures for the applicability purpose. Something like that. But as long as we know that the guardrail system can support and withstand 300 kilogram minimum weight capacity equivalent to 900 pounds. Something like in your conversion factor in algebra, as far as I could remember, 2.2 kilogram is 1 pound. As far as I remember, 1 pound is equal to 454 grams. Okay, then if you try to convert it, it just have the same value. Okay, this one again, 2.2 kilogram is equals to 1 pound. Okay, and then 1 pound is equals to 454 kilograms, if I'm not mistaken. Okay, and 1 tons can be divided into long ton and short ton engineering. So if we mean ton, immediately that could mean standard ton, which is equal to 1,000 kilograms. Okay, 1 ton is equal to 1,000 kilograms, something like that. Okay, but we have also the long ton, right? So long ton and a short ton. So if we mean ton only in a book or a textbook without putting a short ton or long ton, that could mean directly understood to be a ton only. So 1 ton is equals to 1,000 kilograms unless specified that it is a long ton, because the value will change out of that. Something like that, okay? You got my point? Okay, something like that. So it can the guardrail system, which is composed of the top rail, middle, and two board, can support or withstand a weight capacity of 300 kilogram or 900 pounds. Something like that. Okay, going back to the number 2 part. I will separate also the function. Number 2 will be the puncheon or the false upright. It's the same, technically. The false upright and the puncheon is just the same. Okay. Okay, Sir Sotero, what is a puncheon and a false upright? Okay. By the way, class, you can gain this technicalities information if you join OSH safety training, specifically on Bosch basic occupational safety and health, or it could be better, you will choose the COSH, construction, occupational safety and health, because this is just basic. It's not really that higher enough. Okay, because there's a lot of higher enough OSH talking more on the management safety level, something like more higher than this. Okay, because this is only on the, you know what I mean. Okay, for the entry-level safety officers, something like this. Okay, so the ponchon or false upper. But then again, we need to know this because this is the basic foundations of OSH, occupational safety and health professionals all over the world. Okay, like that. Okay, this is ponchon or false upright. Sir Sotero, what is the ponchon? Can you show me? Oh, this is the ponchon. Can you show nagbarog diri? 1 and 2 is the ponchon, ponchons, and the false upright. Sorry, plural. Okay. English grammar. Okay, we have the vertical pipe and the vertical pipe here. So this is the ponchon. But the ponchon really is closer to the entrance. This is the ponchon, okay? The vertical pipe near the entrance, right? If you have a scaffold platform, there's an entrance where the people were to go as an access and people doing the job there. So that first vertical pipe, very near in the entrance or access of the scaffolding platform or work platform, that is the ponchon or the false upright. It's very clear, right? Okay. Number 3. Okay. Couplers or connectors. Couplers, connectors, and clamps are just the same. Don't be confused, huh? Okay. Couplers, clamps, or connectors are just synonymous with each other. Only the terms vary but have the same purpose. Okay? Something like that. But then again, this is part also of scaffolding. Because without the couplers and the clamps and the connectors, then your scaffold structure will be very loose. It will be shaky, and there's no stability, and then your scaffold structure will collapse. Okay? So you have to have these connectors, couplers, and clamps to add strength, rigidity, stability for your scaffold structure so that it will sustain to support personnel, tools, and equipment. And I thank you. So that would be our couplers, clamps, and connectors as our number 3 parts. Okay, like that. And our couplers by technical specification based on OSHA standard pattern in Saudi Aramco technical specification that would meet also European standard number 74. Okay, you have to choose. You buy the connectors, for example. We are not dealing with the couplers here, not already the scaffold tubing. Before I discussed, right, the criteria, specifications for the scaffold tubes to buy. Now also, you will guide the purchaser in your procurement department to choose couplers that have a marking of E, capital N 74. So it is marked with EN74 because that is very safe as a scaffold structure with high quality and a very, very safe couplers, clamps, and connectors. Okay, EN74. Always basing with European standards and American standards, OSHA standards, because they are the parent standard regulatory body all over the world. Okay, there's no other. Only European and American standard regulatory safety legislations and laws to be applied as our parent, meaning we have to put them as our foundation to have a guidance in our works in outside those territories. For example, in Asia, in the Middle East, we still use that guidance as our safety standards, even though we have our own local safety standards, but still we have to pattern that to our parent or main global safety standards coming from the United Kingdom or the Europe countries or the UK and the United States of America. Okay, that's what we have ISO, okay, International Organization for Standardization, ISO. Okay, like that. So number 4. Okay, we're starting from the upper level and going to the downside, right? Okay, Oh my gosh, it takes me too long to discuss this because I don't want to discuss with you if I am not very detailed. I want to be detailed as much as I could. Something like this, okay? And then we have the ledger or runner, okay? Number 4, ledger or runner. Okay. This is very important for safety professionals, okay, because we have to check this every day. It's a part of our safety inspection and monitoring at sites also, in our site works. This is only, not only very, very, very important basic safety monitoring and inspection. We always discover and do that safety inspection of scaffold structures, whatever types. Okay, that's part of our inspection. Okay, so I can say we should learn this if you are of safety officers, safety inspectors, or shall I say safety advisors, whatever. Okay, OSH department. Others also will try to learn this, the basic only, because they're not interested to the parts, but at least they have an idea. Okay, something like that. That's why I'm here to share information with you regarding scaffolding safety, right? The ledger and the runner. Okay, like this. Oh, so Sotero, what is a ledger and a runner? Oh my gosh. So this one, we have here the 2 board. And this one, horizontal side view ha. So this is actually square or rectangular in dimensional aspect. Dimension, right? If you speak, about dimension, you have the length and width, L and W. And so we have surface area. Length times width, something like that. Okay, so the ledger and a runner is understood to be a square or a rectangular in shape. It depends on the type of load rating you have. There is a low duty scaffold, medium duty scaffold, and heavy duty scaffold. It depends on the situations, because at that time you will troubleshoot or determine how many people will be there. The big load plus the live load. Later, I will be discussing the technicalities regarding the capacity or the safe working load. But I'll just discuss this for a while. Okay, the ledger and the runner. Okay? Okay. This one. Ang hirap, no? Because there's no animations, this kind of lagging, and I always use the pen to do this. So how I wish I could do this on my side to do this live stream, but I don't know how to do that. I am not really a computer, expert to do that. Okay, to have creativity on my live stream and I just always showing the paper, blah blah blah, so on. So, but don't you worry, just listen to the substance of the information. Okay, it's very clear, right? Okay, gosh. Okay. The ledger and the runner is the foundation of your boarded blocks, okay, in which you have to plot that one to your ledger and runner to add stability, okay, something like that. So let's just try an example to be a rectangular ledger runner. Okay, this is a pipe like this, okay. So let's just try to imagine and understand, okay, because this is not a perfect drawing, okay. This is just only an illustration to understand the basic safety points of view, something like that, okay. Like this. This is understood to be on the bottom foundation of your boarded blocks. This is the ledger or a runner. So this is a pipe, a scaffold tubing meeting the specification. I discussed it already. ASTM A370 and EN 10200-1. Okay, for the scaffold tubing specifications, I remember that one. Okay, it meets the criteria for that. Okay, and the steel tubing also will meet the scaffold requirements. Okay, the criteria to be checked. Okay. Like that. So it will just be like this. Okay. I'm just doing like this because for the purpose of my discussion. But when you erect the scaffold structure, this runner ledger will be positioned like this. Okay? Because you will put the planks here, boarded planks here. 1, 2, 3, 4. So, in short, you cannot see the runner and the ledger if you are on the top. You can just see when you are at the bottom to see the runner and the ledger, okay, or on the sides, okay, like that. You can see that, but if you are on the top view or the aerial view, you can never see the runner and the ledger because it's covered by the boarded planks. So this is the runner and the ledger. This is the number 4 parts, okay, like that. And by the way, we need to discuss before going to other parts of the scaffolding. We need to discuss first the type of, capacity or the safe working of a scaffold. Okay. So depending on the applicability and the design for a scaffolding structure which is to be calculated by the, I think so, scaffolding engineer, but there's no such BS scaffolding in your college days, or there's no universities and institutions all over the world that offers a curriculum regarding scaffolding engineering. There's no such like that. Okay, you will become only scaffolding engineer when you are working already in the field. That's why you will label that scaffolding engineer. But there's no BS scaffolding engineering in universities and institutions. But what I understand, most of those people to become a scaffolding engineers are mechanical engineers, mostly. But I'm not telling everybody, but I think most of them are mechanical engineers. Actually, one of the requirements to become a scaffolding engineers. But actually, anybody can be a scaffolding engineers as long you study it and you complete a rigid training course regarding scaffolding erection, dismantling, modification, alteration from a third party or an external training organization. For example, TUV, VLOZ, and other third party or outside training organizations, and you finish that requirement, then you can already be called as a scaffolding engineer, but it depends on the situation if you are also hired to be on that title or designation. Of course, how can I call you a scaffolding engineer or a scaffolding inspector if your position is not that? Okay, so that's what I mean. Okay, but I am very, very pretty sure that there's no Bachelor of Science in scaffolding engineering course. Okay, I think there's a safety in European countries, United States of America, and even in India. Bachelor of Science in Occupational Safety and Health, but we doesn't offer that in the Philippines. Okay, we don't have a course on safety. Okay, we have subject only industrial safety under the curriculum of all engineering courses in our country of origin, but we don't have a separate Bachelor of Science major in Occupational Safety and Health course. We don't have that. That's why in our country, we have a lot of safety training organizations as a business, okay? Because they take the advantage to do that because it's a money business, because we don't have that course in our university. Because if we have that course in the university, and then we know that that is a very demand job designation at present all over the world, because we really need a major requirements for safety professionals all over the world, then the safety training organizations or training centers will not be in demand because they will choose to study the course. Why doing that for training only? 1 month, 2 months, 3 months only. Okay, but there is a course that is complete. And after that, you will become a safety engineer automatically by taking up BS safety engineering, right? So why take a training? You pay also there for 2 months or 3 months, and you have a course, complete course for 5 years. Of course, the 5 years coverage in OSS specialization is more rigid than those training centers only 3 months, 2 months. The learning you will learn is not very that rigid compared to a curriculum, 5 years Bachelor of Science, major in Occupational Safety and Health Engineering, or in short, BS Engineering, Safety Engineering. But we don't have that in our country. Okay, only training centers. Okay, me, disclaimer, I'm not really that wanted to do this, but that is based on my opinion. Okay, it's better to have that. Okay, because since we know we are safety professionals overall are very demanded, even up to now. Really, okay, even in my emails, there's still a lot of emails I received. Okay, from different companies in my personal email. Safety engineer hiring, blah, 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 so on. So I'll never entertain that already because I'm working now. Okay, so there's a lot of offers still, even though I'm working already. Okay, so you know the difference. Okay, like that. Okay, so that's why. So they take advantage. No, it's just okay. No problem with that. But for my opinion, okay, like it's better to have a separate curriculum, BS Safety Engineering in the Philippines. Okay, not just a safety training centers. Okay, for me, in my own opinion. Okay, like that. So number 5 will be so that we can explain in detail different topics of occupational safety and health because occupational safety is very broad. Okay, we cover all engineering disciplines from mechanical, from electrical, from a lot of engineering courses. We studied everything that in OSH. Okay, we deal with electricity, we deal with mechanicals also, equipment, we deal also with chemicals. So we are not only focusing in one specialization. That way it's very, it's very hard sometimes to try to argue and debate those technical peoples, okay? Because they are specialized, okay? Because we are on the more on the overall perspective, because we are interdisciplinary or multidisciplinary discipline. Okay, we cover all the disciplines. Okay, it's under in our discipline. Okay, something like that. So number 5, beer's transom. Okay, what time is that? Oh my gosh. The bearer's transom, we have the immediate bearer's transom, like that, the main bearer's transom, like that, the tertiary bearer's transom. Okay, the bearers and the transom is here, putting here in the ledger, like this, like this. You see the difference? And like this. Okay. These are the bearers of the transom. So the main and the intermediate, the main is the center, something like that. It depends on the situation. If you have so many bearers transom, we have the intermediate bearers transom, main bearers transom, tertiary, blah blah blah. But that is only term to be used. But actually, all are the same. Bearers transom. It should be put on the ledger and runner before the plants or the boarded plants. Again, you can never see this bearers and transom in the top view or aerial view. It should always be in the downside view. Okay? Like it should be covered with the plants actually. Okay? Number 6. Okay. We're going down, huh? Number 6, we have the diagonal cross braces. Okay, or simply the cross braces, because when we speak about cross braces, like that, like this, inclined to, I think, 45 degrees. Okay, and then like this, just less than an X, like that. So this is the cross braces. So we mean already that is diagonal in possession. So actually, if you mean cross braces, that is diagonal. So that's still the same. Cross braces or diagonal cross braces. Okay. Cross braces are divided into 2. Okay. We have the longitudinal facade braces. Oh my gosh, facade. The spelling is Facade. Facade. Okay, very difficult, right? If you pronounce this, it will be facade, but the pronunciation is facade. The spelling is F-A-C-E-D-E, like that, facade. Okay, not facade, facade. Okay, difficult, right? Okay, longitudinal facade cross brace. So this is the very long diagonal from the kicker lift or base lift. I will discuss later the kicker lift and base lift. Okay, from the kicker lift or base lift going to the bottom part of the boarded planks. Okay, meaning a very long diagonal cross brace from the ground to the bottom of the boarded planks. So that is longitudinal facade cross brace, but still a type of a cross brace or a diagonal cross brace. Another type will be, my gosh, too much. Okay, we have a transverse sectional cross facade. Transverse meaning half only, or sectional. If this is the section here, meaning section one section of a scaffold, second section of a scaffold, like that. It's only here, section to section. Okay, that is a transverse sectional cross brace, the half or the smaller one. So by common sense, if you go to the field in a construction site, okay, let's just take an example of construction site because the tower plants or in running plant, complete scaffold structures are not very common, okay, because it's already. So we are trying to have an example. This construction industry, we can found this one. If you see, there's a small cross brace, automatically that is the transverse sectional cross brace, and the longer one, that is the longitudinal facade cross brace. There are two types of diagonal bracing or diagonal cross bracing. Okay, like that. So number 7, we have the posts, okay, or the standards. Okay, nag-ibog na po mo sa number 7 sa, because posts or standards. Sir Sotero, why standards? Okay, the standards term here is technically the same as post, nominated and designated for scaffolding point of view only. Because we have also safety standards like that. It's just only a homonym in English, meaning terms that have the same spelling but different in meaning. So that is homonyms. Okay, because there are also synonyms, words different in terms and different in words, but have the same meaning. That is synonyms. And if it is contrary with antonyms in English. For example, bad, good. The opposite in meaning is the antonyms. Okay? But the synonyms, for example, brave, and then the same as fearless. Okay, that is synonyms. Okay, and then if we have also standards and another standards, the same words and the same terms, but different in meaning, that is a homonym in English grammar. Okay, something like that. Okay, so the standards here is just the same as the standards are but different in meaning. Okay, do not be confused. So the standards here are the posts. Okay, the vertical path, the 4. 1, 2, 3, 4, and the foundation of the scaffold structures, vertical posts or vertical standards. Okay, we go to number 8. We're going down, right, from the personal scaffold. Number 8. Okay. Oh my gosh. Wala na akong papel. Charot. Number 8. It's gonna be like this. Kicker lift. Kicker meaning patting. Kick. K-I-C-K-E-R. Lift. Gahit ha gahit. Lift. Not left. Because I. Lift. Kicker lift. Okay. And pace lift. Something like that. Okay. Though I pronounce it very well. Kicker lift and pace lift. Something like that. Okay. Number 8. Okay. Ano siya? Awkward, right? Masaya. Ano siya? Pareho. This is the same with the kicker left and base left is just the same, like a runner or a ledger. But the only difference are two. This kicker and left or the base left have no boarded planks on the top of it. Okay? And there's no two board, there's no top rail, there's only a square downside to add support against stability of the foundation or which scaffold structure. Something it's just the same like that, right? But in a downside. Okay, like this. I will show you. Okay, 4 posts. Okay, like this. Okay. My goodness. I will just put check that signifies the kicker left. This is our kicker left and the base left at the bottom of the scaffold structure. So there's no boarded planks. Only the square in dimension scaffold tube pipe. Okay, it's very clear, huh? Kicker left and the base left. Okay, number 9. We have the base. Okay, the base. Okay. So the base plate. Okay. The base plate clause is a metallic material. Okay, it's not a wood. Just try to remember that one. It's not the same with a solder board, which is a wood. Sometimes people will mix this up. Okay, base plate is really a metallic material that you will put inside the vertical post. You put that inside there to add again stability and support of your foundation to the ground. You put that at the top of your solder board, which is a square in dimension, a plug that has been cut in a square like this at the bottom foundation in the ground level in your scaffold structure. Okay, base plate has a dimension of 150 millimeter to 150 millimeter to thickness of 1/4 inches or 6 millimeter. Okay, meaning to say length times width times the thickness. So that is the dimension of the tip plate, okay, or the base plate. Okay, like that. You know the dimension, right? The more to draw, right? Length, width, and the thickness. It's very easy, right, to understand. 150 millimeter by 150 millimeter, okay, and thickness is 1/4 inch or 6 millimeter. So if you try also to get exactly the inches, okay, we need to convert the conversion factors. Because I forgot to memorize all, right? I forgot because we need to memorize all units because we have the conversion factor, right? It's very easy to understand, okay? Like this. 1 inch is equal to 2.54 centimeter, right? So from centimeter to millimeter, blah, 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 we can obtain the inches from 150 millimeter, okay? We'll just, at least we have only 1 unit specified there, and bingo, we can get the other units also, okay? That's the standard dimension of the base plate. Okay, number 10, we have the sole board. Okay. My God. The sole board is the same as timber seal. TIMBERSILLS. But this timber seals are most commonly used in some scaffolding reference materials. Most of the terms used there are the sole boards. It's more familiar with, okay, but it's just the same for a timber seal. Wood, Okay, it's very clear. The timber seals and sole boards are wood or timber. It is not a metal. Only the base plate is the metal. Okay, do not interchange the two. Unless it is a two-plate. A two-plate is a metallic material and a two-board is a wood. Okay, because there is also a structure that having a platform that is already a metallic floor or a grating. So they put there a two-plate instead of a two-board. Specifically, two-board mean a wood. Okay, meaning made of timber wood. But the two-plate is a metallic material. Okay, there's a difference. Okay, two-plate and two-board have the same purpose, but the same in construction materials used. The two-board is a wood. The two-plate is a metallic material. Okay, or a metal. Okay, something like that. Okay, just like this here. The base plate is the metal and the sole board is a wood. So if I will include that here, something like that, top view only. Okay. Oh, there's also paper. Okay. So this is the base plate, and this is your front toast. Something like we will put that here. Okay, and then you have your sole board here. Okay. Okay, this is the sole board. Made of a timber. Automatically plus timber is a wood. Okay. And this plate is a metal. Okay. Like this. Vertical post. Okay. Base plate and sole board. Okay. Very clear. I don't have to repeat again the dimensions, already discussed a while ago, right? Okay. Something like that. I forgot pala, there's one type of scaffolding which is cantilever. Okay, I registered in my mind now. Cantilever. A cantilever scaffold structure have so many outriggers, okay, erected at the edge of the building structure. Okay, have outriggers to add stability and support to avoid collapse of the scaffold structure. Okay, because the collapse of the scaffold structure can cause fatality, death, and major injuries in working at height. Okay, 60% above recorded all over the world in working at height. Okay, that's based on survey statistics on OSH conducted by United States of America OSHA standard. Okay, number 11. Okay, number 11. Of course, the most important, I think so, it's most important, right? The safe access and egress. Okay, where you climb to go up and you're going to down to the downside or the ground level. So you need to put a ladder. The ladder is a scaffolding aluminum ladder to be used. Okay, like that automatically, okay, because scaffold structure is normally not designated to be installed near the power energized lines or the line electricity. That's why by general concept, you have to have a ladder which is aluminum, not the wood. Okay, we have the 3 meters and we have also the 6 meters. It depends on the sections to sections of your scaffold structures, or it depends on how high your scaffold structures really are. Okay, so this is the ladder for the safe access of the people in going up and in going down, something like this. Of course, if this is a ladder, then you need to follow the ladder safety requirements. What are those? Okay, always face the ladder when you climb, go down, face. Okay, do not like this, like this. Okay, focus. Okay, 3:1 point contact. Okay, 3:1 contact, or 3 points of contact. Okay, 2 feet, one hand, two hands, 1 feet in a run. Run in the horizontal or the scaffolding ladder. Okay, number three, never carry a tools or materials going up. Okay, like that, and the ladders be erected 4:1 ratio degree of inclination. Okay, and then like that. And then if you bring material or tools, you will be able to hoist that in a pulley, pulley, or by means of a rope tied with a stack or a band from the ground level, tie it, and you will be able to pull that up there by means of a rope, a rigid rope, or a very strong rope, or it could be a wire rope pulley attached on a gym wheel, GINWHEEL, attached, fixed properly in the top rail of your scaffold structure. Since some companies don't have that also, then you have to use only the rope, okay? Especially not use all the time, then you have the rope. Nylon rope will do, but the most appropriate for that is the chain wheel with a pulley. You have to pull that one, and the pulley must be inspected properly. There's no sign of breakage or cuts or whatever, or serrations for the textures of those wire rope or pulley, the materials, I mean, okay? Like that. Those are the four basic ladder safety that will be able to use by workers or even people in going up to the scaffold structure and going down to the ground level from the scaffold structure outside, right? So that is ladder number 11. Okay, what else? If I forgot or missed something for the parts of scaffolding, okay, outriggers is not a part because it's only optional. If you erect some scaffold, then you have to put outriggers. It depends on the situation. For example, if your solid or ground are loose, not level, something like that, then you have to put more outriggers of the scaffold structures, of course, or you will make it plain first, compact it first by adding some soil and sand, and then after that you have to use what do you call this one? I forgot the term of that equipment. Okay, ruller, ROLLER equipment, and it will compact the ground after backfilling of the soil and the sand. Normally, construction industry are doing that one because most of the ground also are not level 100%. And even surface of the ground, we need to plane it first. It will become even, so that it will add stability or improve the foundation of the scaffold structure to avoid and prevent the collapse of the scaffold structure. Okay, before erecting the scaffold structure. So there is a scaffolding engineer and scaffolding inspector that will guide and supervise this certified scaffolders during the erection of that scaffold structure. Any questions so far, class? I think there will be no questions anywhere. It's very clear, right? Okay. Now, let's take the specifications, and now we go to the three types of duty. Okay, the low duty, medium duty, and heavy duty scaffold structure. Okay. Again, these are what we call the load rating. When you speak about load ratings, you know to calculate the load limit. Okay, you know to calculate the load limit. Certain kind of load limits for what? Okay, of course, for the weight of the people that will go to the scaffold structure, for the weight of the tools that you'll be able to put to the scaffold structure, for the weight of the equipment they'll be able to put to the scaffold structure, and of course, the weight itself of the scaffold structure, which is the dead load or the dead weight of the scaffold structure plus, okay, the 4 times of the load or the live load. Okay, let's discuss. Okay, you know the technicals for this, huh? Okay, if you want to become an OSH professional, okay, you have to study, okay, and really have a sort of, calculation. Gosh. We're trying to have here a sort of small algebra, okay? Basic mathematics. Oh my gosh, like this. Okay. Or the safe working load, okay? The load capacity of a structure that will sustain for its intended load, that is the safe working load, okay? Like that. Or SWL rating. For that SWL rating for scaffold, we need to determine the safety factor, which is the 4:1, okay? In order we can have the strength, the rigidity, the stability of your scaffold structure, then we need to determine the load limits as per as its load rating, okay, with having a safety factor of 4:1. Safety factor then so safety for the weight, so that it will never collapse. It's very self-explanatory. Okay, like that. Okay, so we have the load rating. I don't tell you because some questions also say like this: what are the 3 types of load rating of a scaffold structure? And otherwise, tell like this: what are the 3 types of SWL of scaffold structure? It will be just interchanging the terms, but just have the same. Okay, and some also will say, what are the 3 capacity type of a scaffold structure? But the answer is just the same: low duty, medium duty, heavy duty. Okay, only changing the words, but it means the same thing. Okay, just like and also board examination. Okay, in the Philippine Regulation Commission, sometimes they will use terms that are not common to the students while they are still studying. Okay, that's why some will be confused. So the only can get that to those people who are very studious enough that kept on reading in the library. Okay, kept on reading, studying a lot, and explore aside from the instructions and learning from their instructors and professors. That would be an advantage. So we need to say it's not enough listening to the instructors and professors. You need to have your own initiative to study more. Okay, for example, if this is the lesson 1, chapter 1, yes, listen to him carefully, but you'll go to the library and go to the chapter 1 and then read the chapter 2 at a time. Okay, so that in the next morning you are very well versed enough to answer all the questions for the chapter 2, in which the instructor start to discuss. Well, you have an idea already what the instructor and professors are discussing in the next morning. Okay, go ahead of time after taking the present lesson and the present chapter. That is the technique of passing the examinations to whatever examination you'll be able facing in the future. It could be an employer test, entrance examinations, or whatever. Okay, so plan ahead of time. Do not focus on the present, chapters and lessons. If you know them all, then go to another lessons to have a pre-learning for the next chapter and lesson. Okay? And then memorize the key important terms, the important terminologies. Okay, because sometimes the instructors and professors will never discuss the definition immediately in the class. Okay, they will just go directly to problem solving. Okay, because it is understood that they already read the books. Okay, because the phrase in your books, then if you have the books, then you have the right to read the lessons, the introduction of a particular topic. No need to wait for instructors to push you to read the lessons. Okay, like that's a technique if you're a student right now. Okay, you should study ahead of time, not only for the present chapters, present. You should be advanced. Okay, something like that in your study, something like that. Even though nobody teaches you to study that one. Okay? In the future, it will just come out in the examination and you don't know. Okay? For example, again, who discovered penicillin? Okay? Who discovered penicillin? If you just read books, it's Alexander Fleming. Who discrimination? The story, they cannot answer that because they are not reading the basic foundations of basic chemistry, we focus on that problem solving directly. Okay? Like that. So, we have the load ratings. Again, who discovered penicillin for treating wound is Alexander Fleming. Okay, something like that. Okay, load rating. Okay. And if you write something, it will work into your brain, okay, for a couple of years, for example, okay, it will register to your brain when you reach 50 years old, 60 years old, it will just be in your brain all the time, okay? For example, density is equal over volume. Even though your age will become 80 years old, you still memorize that formula, okay? Even though you cannot walk, you are very sickly. But if somebody asks you, what's the formula? You can still answer despite of your age. Okay? If you memorize and understand the learning for the basic formulas of science and mathematics. Okay? Something like that. So low brain. Okay. Low Judy. Gosh. Talaga? Yes. Oh my gosh. Time check na talaga. In fairness. Low Judy. Low Judy scaffold. Okay. This is a scaffold for our work and at high doesn't need too much equipment or tools. So the load rating will be adjusted for that. Or there are less people involved to do the work. So you don't have to let a very heavy duty for common sense, right? Okay. So the load rated scaffold will be from 120 kilogram per square meter. Wow. 120 square meter. But you know, to memorize this. Okay, memorize. Because the conversion will be converted to, let's say, okay, memorize. Because the conversion will be converted to, let's say, kilogram per square inch. And we know that 1 inch is equal to 2.54 centimeter, blah, blah, so and so, and centimeter will be equal to, okay, kilograms per inch. Okay, this is KN, kilogram per square meter, KSM. KSI, kilogram per some students, especially if they are not reading too much, okay, kilogram per square inch, just like a pressure, PSI, okay, like that. So spur understandable, something like that. Okay, so if you have to convert, then go to the conversion factors. Okay, and then the medium duty will be, okay, medium duty will be 200. I'll tell you something, I have to share with you why. Okay, I'm confused also. Okay. Because this is really from Saudi Aramco standard. It's just only like an error, but I don't think so because in Saudi Aramco, their safety compliance is very strict. They can terminate any individual who doesn't follow safety without any question. Okay, without any habibi or close those guys commit mistakes, heavily or too much mistakes. It's only the hand gloves, the light gloves, the mask can sometimes terminate, something like that, with strong compliance for the safety. Okay, number one is really Saudi Aramco. Okay, strict compliance of safety program. Okay, heavy duty. If they said warning, warning. If they said terminate, terminate. Okay, there's no adjustment for that. Okay, and that's a very effective disciplinary action, safety disciplinary action, to eliminate those unsafe actions and unsafe behaviors in the field, which are the main causes of potential accidents. Right? It's always the unsafe behavior and the unsafe actions of the people or by human factors equivalent to personal mistakes, personal errors, personal negligence, personal carelessness, or 90% up to cause an accident. And I thank you. Okay, heavy duty will be 250 kilograms per square meter. Aha. Wow. This one. Wow. This one. Uy, tama mga kapatid. Ano ba ito? Three types of load rating. With load shoulder equal to 120 kilograms per square meter to 130 kilograms per square meter. Medium duty of a scaffold, 200 kilograms per square meter to 250 kilograms per square meter. Sorry, times 12. And a huge duty scaffold, we have above 250 kilograms per square meter. Okay, and you can convert that to half kilogram per square inch. Okay, conversion factor. Okay, now I will question you. Sir Sotero, what happened to 141 to 199? See, it doesn't specify here, right? Okay, like this. Then below, up to 140, what will happen to 141 kilogram per square meter to 109 scaffold load rating. Okay, now in this unit kilogram per square meter, you can get the specific capacity. Okay, why? Because surface area of a structure that could be a rectangular shape or a rectangle or a square. The flow area is equal to length times width. Okay? Granting that this square with equal size, the length is equal to the width. That's why in algebra, you have to put A is equals to S squared. Because length and the width is just the same, just equal. Okay, so A is equals to S raised to the power 2, and S means the side. S-I-E-E. Be sure to put a nomenclature that starts with the word. For example, length. So your abbreviation starts with L because that is length. Do not also use a letter that is not belonging to the term. Okay, for example, length and use P, kalukuhan. Okay, because that is not P, that is length, that's L. Use L. Common sense, right? Width, use W. Why use another letter? It's not related to the word there. Okay, the first letter of that term should be used. Okay, length times width. L is the first letter of the length. W is the first letter of the width. So the surface area of a rectangle or a square is equal to area is equal to length times width, regardless whether the L and the width is capital letter or small letter. Okay, regardless, as long as those are L and W. And the same, so automatically P equal to A is equals to A raised to the power 2. Okay, or S times S. Okay, that's why S squared. Okay, because of this side. Length and the width are all general side. S-I-D-E. Could it be a length? Could it be a width? That's still the same side. That's why we use S. Okay? Surface area square is equals to S squared. Surface area of a rectangular shape or rectangle, A is equals to length L times W. Okay? Ganun siya. And now, you're going to apply that here. In our low-duty scaffold, we have 120 to 140. Now, kilogram per square meter, we have the denominator of square meter. So if you multiply that to the surface area, the denominator square meter will be cancelled out. So what left is the kilogram. And remember, kilogram is the unit of weight, capacity, and the force. Okay? It's just the same. Okay, unless gravitational force are being inserted in our principle. Because if you use the gravity, the force and the weight will never equal already. because you are using the acceleration due to gravity, which is equal to 9.81 meter per second squared. Okay? So that's why your weight on the Earth is not the same in weight in the moon. Okay? Like that in terms of force. But your weight in terms of ground may be the same. Okay, because you are not trying to incorporate gravitational pull energy, which is the gravity. Your weight on Earth is not equal. Your weight on Earth is not equal to the weight on the moon because the gravity has been considered, which is 9.81 meter per second squared. Acceleration due to gravity, something like that. Downward pull, gravitational pull energy of the Earth's surface. Okay, so that's the purpose behind for that. And if you cancel that area, okay, we are not floating. Okay, we are inside the Earth, so we don't consider the gravity for this. Okay, like that. So if you multiply, so cancels out the denominator. What's left is the numerator. So kilogram. So it's very easy class that if, okay, let's plan how many people go there and then plus the equipment. It's very easy if we have this guidance or load duty. Now, I will add this theories that we can really learn. Because the weight is not only intended for the deep weight, it's also the live weight. Okay, the live weight will be, this is not the same with science, because science is, for example, living things and non-living things. Living things are those having life, right? The plants, the animals, the insects. The non-living things are those materials that cannot breathe, okay? No life. But here, the life load also considers equipment and tools. But equipment and tools have no life, right? You don't have the digestive system, you don't have the physiology inside their immune health system like this, but they are considered live load. Okay, so now we are having the live load of the scaffold structure. Live load is equal to the weight of the plus the weight of the tools or plus any materials that you are going to put in that work scaffold platform. Okay, even though the spanner, the welding rack, the cables, everything, okay, calculate that one by estimation only. Okay, it will take you how many days to finish for your computation. Okay, live load L. We visit it as L because the word live starts with L, right? L. This is live load. Okay, live load L. Workers or people. Okay, tools, equipment, okay, any materials, blah, 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 so and so, okay, H, etc. Okay, W is the weight of the scaffold structure, okay. Weight of the scaffold structure or scaffold means the capacity or the self-working load. Okay, just the same thing as WL, self-working load or the capacity that the scaffold structure can support. Okay, like that. So our formula here will be the SWL, the capacity or the weight of the scaffold, or let's say W is equals to, okay, the dead weight plus 4 times the live load. Okay, dead weight. Dead weight patay, right? So dead weight, meaning to say this is the weight of our scaffolding parts, the 16 parts I discussed already. Okay, so these are what we mean by dead weight. The total weight of the scaffold structure, all parts. Okay, like so this is the dead weight. Okay, so okay. So if we have the formula which is W is equal to D plus 4L, then we can compute the capacity for this equation, for the scaffold structure. Regardless, it is a low duty scaffold, medium duty scaffold, or a heavy-duty scaffold, we can compute the capacity, safe working load, or the weight equal to, okay, the dead weight of the scaffold structure, okay, the total weight of the structure, or plus the 4 times this live load, which is the weight of the equipment, weight of the tools, weight of other materials, and the weight of the people or workers in the platform of the scaffold. Okay, so very clear. So if you do that one and then try to equate that one in equilibrium to your load rating. Now, if your capacity is higher, W is higher from the load rating I mentioned a while ago, then your scaffold structure will collapse. Okay, so it could happen you erect the medium scaffold or the heavy scaffold for that. You know, they can estimate this by thinking only, and bingo, they can do this because they are very experienced people also with regards to scaffolding. Okay, because they are trained, like this, knowledge, experience. So no need really to focus this one by one, but we are only giving you the exact technical specification requirements, the logic behind. Okay, so only an overview. But those people really know they did their assignments also very well. Unless they are working like that and scaffold materials standards doesn't meet with the technical specifications I mentioned a while ago, right? Then there's no time the scaffold structures will collapse because some materials are being inserted there for the erection. So that's not good. That's improper. Most of the improper thing will produce unsafe thing, and it will produce accidents in the future. Okay, plus the actions of the people. Okay, human factors really are the number one of accidents. Okay, because even though how safe is the unsafe is the scaffold structure, if nobody goes there, nobody will die. Correct or not? Nobody will be injured. Okay, that's why in scaffolding safety, we need to have periodic inspection every 7 days in construction industry. But in general industry, we need to check regularly. No need 7 days like this, no specific, but we need to time check only, periodic, no specific, periodic. But in construction, every 7 days, there's a specific requirement. 7 days inspection of the scaffold structure. They have to put red tag on the structure. They have to put green tag if it is a usable scaffold structure. But in general industry, putting of a scaffold tags are not really that a major issue. As long as the scaffold structures are being erected safely and it is inspected by our naked eye, that it is strong, that will be enough. So there's a difference, right, in general industry and in the construction industry. But the same, general concept is just the same. Okay? Like that. So this is the way. So your low duty scaffold, medium duty scaffold, and the duty scaffold based on this computation. Okay? Weight is equal to the dead weight plus the 4 times the live load. Okay. Understand now. In construction industry, by the way, the scaffold really is a type of structure that can support 4 times to its intended load. That's the definition of the scaffold structure in construction industry. But in general industry, it's another thing. This one really applies. Okay. Okay. Any structure can support 4 times to its intended load. Okay. Like that. So we need to say we're considering a safety factor of 4:1. Okay, like or know the load rating. So any questions so far before I end this very long and lengthy live streaming? Actually, I did not discuss the working at height. Okay, going to working at height. Let's make this short. In working at height have 2 safety requirements: primary fall protection system and secondary fall protection system. The primary fall protection system are erecting a guardrail system, complete guardrail system, to prevent workers from falling down the ground level and to prevent objects and materials to fall on the ground level. And the secondary fall protection system will be the wearing of full body harness and the consideration and the application and the implementation of a full arrest system or the self-retracting device like this, a lanyard in going up, in going down. Sorry for the term because I'm not really a scaffolding expert. Okay? Something like that. Okay, self-retracting device attached on your full body harness, and then with anchorage points above your shoulder, lifelines tested and inspected. It could be a horizontal lifeline or a vertical lifeline. It depends, especially if your job is a roofing job. You need to have a horizontal lifeline. It depends on the situation. But in most cases, generally, they have to find a very rigid and strong fixed anchorage points, stable, just like a permanent tapre, like this, and they'll put the hook above the shoulder. Some case-to-case basis situation, okay? Because there are also sometimes situations that you don't have, but that is only a danger if your job requires too much movement in the extension of your hand, body, or the machine, and there's a tendency you will be imbalanced and you will be falling to the ground. So the best thing for maximum safety protection in working at time is to follow both the primary folding tools opening on the platforms and the floors, that you have to cover that one. The safety nets underneath of your work platform so that any potential falling objects will be catch. That is called the catch from the next level. That's what we call a catch platform. It's still a safety prevention system. But since sometimes it's no longer necessary, especially if the job requires to be completed in a very short period of time, so with practical safety approach, we do as long as there's a primary for protection systems. And that's why I told you, if there are really complex situations that produce a high-risk impact with our workers, then the planning of our type of scaffolding structures to be erected will also vary to that. It depends. That's why we have proper planning for the correct utilization of our resources. Meaning to say, we need to check the location first, where to put, where to mobilize our people, the specific work to done, like that, and the materials to be used, so that we can plan ahead of time, the standards materials to be used, something like that. Okay, and all resources to be used. Okay, we have to plan ahead of that. The logistics issue also is very important because we cannot proceed there without transportation. Okay, like that. Everything, the water for the people, like this, the equipment to be used, to everything, blah, blah, blah. Okay, that's very necessary prior to conduct the working at height activities. Actually, the main hazards and risk of working at height and scaffolding activities are merely just the same, because if you work at height, usually one example is the erection of a scaffold. Okay, that's an example, right? The most of the hazards are fall from height, falling objects or falling materials, collapse of the structures. Okay. Number 4, electrocution by the energized power lines or live electricity, especially when you are working topside very near to the live lines or electrical posts. We don't know. That is an example of complex situation. Okay, and you have also the incorrect PPUs or the fall protection system, as I mentioned a while ago, the correct or inappropriate and incorrect full arrest system use. Okay, meaning to say you are using the uninspected or uninspected full body harness, and it will not serve the purpose. After falling, it will just break, and then same story, the people will die. Or the person will die if he falls on the ground. So be sure that the full body harness are completely inspected and all the lifelines are very rigid and strong and inspected prior to use that as a lifelines in order to hook your lanyard there. Okay, something like that. And the last hazard will be the weather condition. Okay, the weather condition, heavy rains, no working at height to be done. Wait that it should be completely dry so that the surface of your platforms or work platforms, so scaffold structures are not slippery. So slippery are danger when you climb, and then it causes accidents and injuries also. Okay, and also the environmental outside factors, especially too much wind. They cannot work properly if there's too much wind. Okay, how can they work properly? And they will just like this, balance again, they will fall. Okay, something like that. Also, if too much sunstorm, it will black their nose like this. How can they work properly? So of course, they will not walk and wait for those environmental outside factors to normalize before going up to the working at high specific locations in your various scope of work to be done. And I thank you. Okay, so any questions so far for the scaffolding or working at height, sharing information? I think it's very clear, right? Okay, thank you so much. And if you and you can also share to else if you want to, and then click the notification bell from Service It's Off. I am a senior eternal voice by coverage on occupational safety and health, sciences, personal lives, health lifestyles. Thank you so much. Bye bye. God bless everybody. See you later. Wow. Thank you so much.